Frame Analysis, Video 4, Loads Part 1. The structure is now defined, and the next step is to specify the loads. We then change from program part input geometry to input loads. This will change the main menu as well as the toolbars on the left side of the screen. The first thing to be done is to define the basic load cases, which later will be combined into load cases. We're going to enter 6 basic load cases in this case. Dead load frame for the specified structure self-weight. Dead load from other self-weight loads for the building influencing the current frame. Imposed load, snow, and wind. Finally, we must also consider the initial sway imperfection, so we will also create a basic load case for that. In this input box, also the type of the load can be defined, which considers the load duration. However, this affects only timber structures, and as the current frame only contains steel, this input can be ignored. We will now show how to specify the loads included in the various basic load cases. The active basic load case is displayed in the upper right corner, and all loads specified will belong to the active load case. Loads are preferably defined with the tools now available at the program's left edge. At the top, we find the uniform load, where the intensity Q is defined. If the load not affects the entire member, the lengths L1 and L2 should also be defined. The uniform load can operate in the global X or Y direction, the local direction, meaning perpendicular to the direction of the member, or as an axial load along the member. Furthermore, the load may also operate horizontally or vertically, meaning at a horizontal or vertical length instead of the total member length for skew members to, for example, simulate snow load. One can also let the current load act on multiple members simultaneously, for example, all members or all horizontal members. If the load acts horizontally, it may instead operate on all vertical members. If we define a load intensity of 5 kN per meter acting vertically and want it to appear on all horizontal members, we make a box around them in this way. We then choose Undo to remove the loads again. The next tool is used to specify trapezoidal loads where the intensity varies along the member. With the tool Joint Load, point loads acting on a node or a moment acting around a node is specified. A point load acts somewhere along a member and is specified as an intensity and a distance from the node to the left. Similarly, a point moment acts somewhere along the member. A joint displacement load means that a node is assumed to be deflected in the X or Y direction or as a prescribed rotation before the analysis is performed. This can, for example, be used to take into account an expected settlement. The tool Temperature Load takes consideration to the impact a temperature difference between a member's top and bottom has. Finally, with the tool Self-Weight, one can let the program specify the self-weight of the structure. We will now specify the loads acting in the different basic load cases.